For decades, biofuels have been used as a clean alternative to fossil fuels and slowly have been implemented into our society in hopes of reducing carbon emissions and making this planet a healthier place overall. Biofuels are mainly used as ethanol and mixed into our gasoline to create a cleaner solution for cars and lower emissions from our vehicles. Ethanol burns cleaner than gasoline, so using biofuels as an alternative seems like a miracle solution. This works in theory, but unfortunately, there are unintended consequences that have made themselves known and are now referred to as indirect land change use, or ILUC. Data from researchers studying ILUC show that since the rise in biofuel use, there has been an increase in deforestation, soil purity, prices of farm products, and other detrimental effects that show that producing and using biofuels is not as miraculous as one thought. This extremely complex problem is what experts today have set out to solve.
A scenario is an alternative image of how the future might be and is often utilized to predict uncertain outcomes. When thinking about contrasting plausible scenarios in relation to indirect land use change impacts of biofuels, only two come to mind. The first of those plausible future states is that biofuels are accepted and urged for widespread use in such a way that leads to significant indirect land use change impacts. This occurring could result in several future effects arising. Perhaps the most notable is the possible increase in greenhouse gas emissions, the exact effect biofuels are supposed to help mitigate as opposed to fossil fuels. This could also cause deforestation and habitat loss. To such a possible extreme, we could see severe biodiversity loss and destruction of many vital ecosystems. Soil degradation, water stress, and impacts on food prices and security are other effects we could see from increased indirect land use change. The need to begin mitigating these adverse effects can start now, in this community. Taking action by promoting sustainable biofuel production, supporting land use change management, enhancing agricultural practices, and increasing public awareness and education could be the spark that causes the change.
The second scenario is the one that we're all striving for, and that is to properly mitigate the ILUC impacts. A possible solution would be to increase the price of biomass from plants and animals. This would increase the incentive for land conversion while also decreasing the incentive for deforestation and the excess production of crops for biofuels. In this case, we have to provide more opportunities and ensure that the cost of land conversion is relatively low. We'd also have to set regulations to limit the destruction of these lands to protect them, and also to ensure the livelihood of farmers and communities in the areas. We would have to promote biofuels, bioliquids, and biomass fuels that are certified to present a low ILUC risk. With individuals adding sparks to the cause, governments enforcing supportive policies, and farmers and communities gaining knowledge and backing these efforts, we can build this scenario up little by little until it's the vision that we are all striving for.
Let's envision a world where we are replacing first-generation biofuels, which have some significant negative environmental and societal impacts, with second-generation non-feedstock. They do not require fertilizers or pesticides, they have less production costs, do not affect the food chain, and emits 94% less greenhouse gases than the 74% compared to first-generation biofuels. What this means is that it reduces eutrophication, it gives agricultural and crop waste a better purpose, and can help reduce climate change. With that being said, combined with land expansion restrictions to help restore the biodiversity, less production costs, meaning better funding and oil extraction expenses, the transition to growing these biofuels in the same arable land makes the risk small, as we can always find better solutions and strive for a better sustainable world.
One of the biggest challenges of ILUC is that it actually cannot be directly measured or observed. It is extremely difficult to isolate just one activity as the main driving reason behind it all, and there could be a variety of different factors that affect land use change. A 2015 study conducted by the European Commission confirmed that only a very select few amount of biofuel feedstocks can actually be categorized as ILUC with a high degree of confidence. So there's a lot of confusion and uncertainty when calculating greenhouse gas emissions and categorizing land use change as direct or indirect for biofuels. However, the implementation of low indirect or no displacement biofuels could combat this confusion and help with our calculations in greenhouse gas footprints. With regional production, low indirect impact biofuels have the potential to divert other crop production expansion into high carbon stock land that we value so much. Additionally, it is recommended that a top-down approach should be followed for ILUC prevention. And this entails identifying and increasing above baseline yield and cultivation of currently underutilized land, and is suggested by Utrecht University. This also entails chain mitigation, chain efficiency, and land zoning, that allows for a much more precise and feasible approach to analyzing and identifying biomass production potential with low ILUC risks.
Biofuels are a possible sustainable solution to fossil fuels, only with the correct production methods. This fuel substitute has the potential to be economically and environmentally more efficient than traditional fuel, but the negative unintentional impacts must be addressed and improved through various measures. These measures include identifying issues, comparing scenarios, and brainstorming a desired vision for the future that benefits all life on Earth. Through these measures, stakeholders can strategize and implement new policies and regulations that centralize coordination with the environment rather than working against it. With the support of stakeholders, new biofuel production will limit competition for scarce resources, deforestation, air and groundwater pollution, as well as harmful greenhouse gas emissions.